Okay, C495. This is the example of space truss that we talked about this morning, and I'm gonna just record this exercise, so I want everybody actually enjoy learning something slightly different, but overall workflow is same. All right, as you can see, I draw this curve. If you want to change, okay, if you want to use this Rhino command, you could click. You can draw whatever just want, right? When you select it, there will be some multiple control point. You select and you can just move around and see that you could play around this curve. But for now, I'm gonna use this. Maybe I can make a little bit, make something more dramatic. All right. Alright, so this is curves. I assume this is my loop structure, right? It's starting at the 10 feet and here, and it goes up. So this might be the cantilever. The column location later on, I may choose randomly, maybe at the end or somewhere here. So first, you need to select and dump this curve to the right? So I'm gonna assign this curve to this curve command. So as you can see, when you just walk through that, obviously this curve is drawn on XZ plane, but I copy the line in Y direction, perpendicular direction at the 30 feet, right, spacing. So since I copied the one curve, obviously with using two curves, I can generate the surface by using loft command. And since I have a surface on the top, I can use the space truss command. So this space truss command, I divide all the panel into the three, and in the longitudinal length, I give default 20. So see that this truss panel, I think it's supposed to be total 20. They generate some space truss. All right, so with that, this space truss structural one command, the primary top one is, I think, is the top chord members, and primary two line is bottom chord, and web member is all diagonal, right? It's web member. So those line is ready. And for this exercise, I also we create the surface model based upon the top surface divisions. So I generate by using this, and I can generate the new shell. So after that, I add a few more, one next step, because whatever just this truss I built, and I copy over 6 times to Y direction. So instead of just practicing with the one, the loop structure as wide as 30 feet, but I'm gonna copy over 6 times. So this is entire, let's say, the truss system. I'm gonna export and import into the SAP. All right, so I think since I exported everything, so let me just bake it and see what I'm getting. So okay, I have all the line and surface all together. All right, surface ready. Okay, curve is ready. All right, so the one thing I should do always, I forget the original curve I use. I'm gonna turn up. All right, here, right, this nerve curve. Since I'm not using this, so I'm not gonna export it. So basically, what am I doing? I'm gonna just lock it, so I don't wanna select the nerve curve. So okay, so I select all the line and surface and export. right into the let me see, what did I use it? Okay, here an IGS file. This is another space truss, but obviously this is a 6-bit, right? So I export it. Okay, then I'm gonna open the SAP. Okay, I'm gonna import all this line and surface as well together. Let's wait. Alright, SAP is opened. I'm gonna import that IGS file. So this is Space Truss 6. So I'm gonna select the curve and surface together. Alright, so see, all geometry actually came imported, right? Since geometry translation is over, now everything is on SAP. So boundary condition and section property, material properties, we want to assign it. In order to select everything, so I'm gonna put 3D object on XZ plane with aperture 0. So here, so I assume this is supporting point here. Maybe we could assume this is the column location here. I'm gonna assign some boundary condition pin connection first for analysis standpoint. And then again, the default material property and section property. See that always W18 by 35 is default member, which we're not gonna use it. Instead, we're gonna use a truss. So I imported some section property, either 6-inch pipe or 8-inch pipe or 4-inch pipe, let's say. Basically this pipe, the section I don't have a material properties. Maybe let's show. Let me just show you material properties. Since I don't have a pipe steel, I could bring a 36. So grade 36 is mostly common for steel pipe. So now, after I import the new material for steel pipe, I'm gonna import the section 6 and 8, but at the time I'm gonna choose right associate section material for pipe. So you see that? So this section property, and I select the material property, so this is all automatically associated. And then I'm gonna select, I'm gonna assign every, for simplicity, I'm gonna use, let's say 6-inch pipe. I assign the 6-inch pipe. And the slab, we have a one default, right? So this one, I just said, default is 1 foot, which is not gonna be a concrete slab. This is most likely metal deck. So I assume this is gonna be just 1 inches. So I convert it to 1 inches, right? So this is, let's say 1 inch, even 1 inch is a lot, but a deck or plate. And then I'm gonna choose some steel instead of concrete, right? So unless this is basically, we complete the geometry we brought. And think about it, if you don't have any skill of the Rhino and Grasshopper, how are we going to generate this geometry in the SAP? Or AutoCAD, you may have to draw it. But anytime that this pattern changes, you may have to recreate it, restudy it. So geometry, development of geometry is really, it's kind of hard. They require a lot of effort. So I want you to learn some tool like a Rhino and Grasshopper, so that your lab is much, will be better, right? All right, so I'm gonna run it. Yeah, default modal analysis, dynamic analysis, I don't, at this point I'm not interested, only just checking overall building behavior under self-fade, that load. So I'm gonna run that model with the only download self-8. I have to save that. Okay, this one is 6 bay. Okay, let's see. All right, it ran. So let me check deformation shape. Okay, the animation is usually okay. I'm turn on the deformation shape and some contour diagram, vertical Z. So if you turn the animations, you see some structure behavior. Seems like the cantilever is extremely significant than backspin. So self-weight deflection and things. That's basically the cantilever tip. Long. This is just the only introduction of the overall workflow from the generating the geometry to initial structural analysis. Eventually, up to here, we cover geometry and analysis. Down the road, we need to now from here, so we need to focus on all the engineerings, some the boundary condition, all the member. If this pipe, I think it's most likely the welded connections, which is okay, space frame. Otherwise, we may using ball connections, spear connections with using small bar type of pipe or rod. We can just explore the many other stuff too. But at least this is just introduction for workflow, geometry development, and export and import to the SAP analysis. So this is at least kind of enough. All right, some actual force diagram I just turn on based upon download. So you can just kind of practice, and this is general workflow. Compression and tension, you see that though, because of most likely we have a self-weight, so top chord experience mostly compression, bottom chord or tension, or the other way around, right? So it seems like this is mostly cantilever. Bottom chord experience compression, top chord experience tension, right? Something like that. So I want you to practice and enjoy learning, and this is actually a cool example for everyone. Okay, I'm gonna stop here and see you next week.